Hi, my name's Ashley and I work for a company called Volume Graphics. More on that later. We're here at one of the world's largest exhibitions for quality control, imaginatively named Control. Why do we need quality control? We'll get to that in a bit too. And why are we making a video about it this year? Well, because this year we've got new neighbours. The Control exhibition is here in Germany, the land of the automobile, or more specifically Stuttgart, which is home to such small automotive brands like Porsche or Mercedes-Benz. And since cars are something most of us are familiar with, why not use them as an anchor for our journey through the world of quality control? So two things set German cars apart as this automotive technology became more ubiquitous. One, perceived quality, and two, reliability. So we'll start with the first one. Everybody's familiar with sitting in a car, driving down a bumpy road, and everything rattles, squeaks, creaks, but not in all cars. Not something you'd associate with a Mercedes, for instance. What do they do differently? Well, a car interior is made up of hundreds, if not thousands, of individual little small components all stuck together with glue or clips. And the better these pieces fit together, the less likely they are to rattle. But in order for them to fit together properly, they need to have really exact sizes. So how do we make sure that they're the right size? Well, we measure them. And that's the first point of quality control. Then next, there's reliability. So nobody wants their engine to go bang. But if it does, it's usually because one of the components will have been the wrong size, the wrong material, or a combination of both. And in order to make sure they keep working, again, we'd have to measure them. How do we do that? Quality control. We at Volume Graphics have been working with these automotive companies for years to reach their quality goals, using a technology called X-ray computed tomography, or CT. You might know CT from such applications as going to hospital if you've broken a bone. But you also do that with these components that we talked about earlier that you might find in an engine or a car interior. So using X-ray technology, we can actually scan something, digitize it, and create a full-blown 3D model of it. So here's an example. We can now move it around virtually in 3D space, or even virtually slice it in order to take a look from varying angles, to have a look inside, if there's things such as cracks or air bubbles, to make sure that the material is up to the job. But even as amazing as CT is, it does have limits. And for the past 10 years, I've always seen quality through the viewpoint of CT. But 2 years ago, Volume Graphics was acquired by Hexagon. And now I have a whole load of new tools available to me. But Corona's been here, and despite being here for 2 years, I've never been able to get my hands on anything. But now I'm looking forward to getting over and trying some hardware. If I were to ask you, how do you measure something? You'd be absolutely right if you said tape measure or ruler. But then the next question is, how do you know the ruler's right? Well, this is the beginning of the rabbit hole known as metrology, not to be confused with meteorology. And metrology is the art of measurement. And if we're talking about accurate measurement, this here is the Mac Daddy. So this machine is where everything begins. All of these other measurement devices need to be calibrated, but this is the one that calibrates the calibration pieces. So this thing here can measure something accurate enough to 3/10,000ths of a millimeter. which is basically as accurate as you can measure things without using specialized scientific equipment. So if you really want to know how something looks and what shape it is and what size it is, this CMM, or coordinate measuring machine, is the real one to do the job. So the way it works is it moves this little probe in space until it touches whatever it's supposed to measure. Once it's touched it, it remembers exactly where it touched it and saves that in the software. Then it moves to the next point and looks where it's touched it and then saves it in the software. And you can see here it's actually running lines up and down. So it can kind of digitize surfaces too. The downside to this super accurate measurement is it is quite slow. But these CMMs have a trick up their sleeve because you can also stick a laser underneath it. Now, the way this laser works is it doesn't take one point like a probe, it takes thousands of them in a line. And then as it moves across, this line just sweeps across the whole thing, digitizing a whole 3D model. It's faster, but less accurate. So then the question is, if that's how you measure stuff, what do we need all the rest for? Well, for starters, not everything that needs to be measured can fit on a CMM. What if you wanted to measure a bicycle or a car door, for instance? So that is where these things come in. They're measurement arms, and they're portable. And I said I was going to get my hands on some hardware. So these things here can just be moved over to wherever you want to measure stuff, and then you run the laser over and you can see the image being created in real time. And it feels a little bit like spray painting. Das ist geil, du. We just mentioned the advantage of being able to hand move something, right? So you don't need to program it. Okay, well, we'll turn that on its head for a second and say, what if you wanted to automate this process? Now, we're all familiar with robots, and you can imagine you just tell the robot to move and scan somewhere. Now, what may surprise you is these robots aren't accurate enough for measurements, because we're talking tiny fractions of a millimeter. So instead of just moving the robot, we've got something called a tracker. Now, no prizes for guessing what a tracker does. So it will track these spots here on that robot and use that as a basis for the measurements as to where the robot moves. And there's a way of automating those laser scanners we just saw around the corner. This is an interesting spot. We've already talked about all the different measurement tools and ways that components can be measured, but we've only done it at a component level. And what self-respecting car maker only makes one of each component? They'll make hundreds or thousands or even millions. So what do we do with all the rest of them? Well, something needs to keep an eye on all of these things that are being measured. And a lot of them can be measured because it'll all be automated. But then what do you do with that data? You need to see, are things getting worse or better? And if they are getting worse, what do you do about it? Well, software like this can see when things start going wrong and then talk straight to the production machines and fix those issues without even any human intervention. Clever stuff. So now I've finally had the opportunity to get my hands on some hardware and get a glimpse into the world of Hexagon. And to be honest, I think it's starting to rub off on me. They're hexagons, by the way.